You've watched water boil 1,000 times, but you've never actually seen what's happening inside those bubbles. Most people think bubbles are air. They're not. That's the first surprise. When you heat water on a stove, something far stranger is occurring at the molecular level, something that took scientists centuries to fully understand. And the story of how we figured it out is just as fascinating as the bubbles themselves. Let's start at room temperature. Water molecules are moving constantly. They collide with each other, vibrate, bounce, but they're not moving fast enough to escape the liquid. They're trapped by invisible forces, hydrogen bonds pulling them together. It's like a dance where everyone wants to leave, but the music keeps them locked in. Now turn up the heat. The molecules move faster, vibrate harder. Temperature is just a measure of how violently these particles are jiggling. As you approach 100 degrees Celsius or 212 Fahrenheit, something critical begins to happen. Some molecules are moving so fast they break free from the liquid entirely. But here's where intuition fails us. The bubbles you see rising in boiling water aren't filled with air. They're filled with water vapor. The molecules have escaped the liquid and become gas. They've traded their neighbors for freedom. The bubble forms at a nucleation site, usually a tiny imperfection on the pot's surface, a microscopic pit or scratch where water molecules can gather and escape more easily. It's like a weak point in a dam. The pressure builds, the vapor bubble expands, and suddenly it's large enough to overcome the weight of the water pressing down on it. Then it rises. The bubble climbs through the water toward the surface. But as it rises, something unexpected happens. The pressure around it decreases. The water above it weighs less, so the bubble expands. It grows larger as it moves upward. A bubble that was tiny at the bottom might be twice the size by the time it reaches the top. And then it breaks. The bubble reaches the surface and bursts. The water vapor escapes into the air as steam. This is the moment most people call boiling. But technically, boiling started much earlier when the first molecules escaped the liquid. What we're really watching at the surface is just the visible, dramatic finale. Now here's something that puzzled scientists for a long time. Why does water always boil at 100 degrees Celsius? Why not 95 or 105? The answer lies in atmospheric pressure. At sea level, the air above your pot is pushing down with a specific force. Water molecules need just enough energy to overcome that pressure and escape. That energy threshold happens at exactly 100 degrees. But climb a mountain, the air pressure drops. Suddenly, water boils at 95 degrees, or 90, or even lower. At the summit of Mount Everest, water boils at just 70 degrees Celsius. The molecules don't need as much speed to escape because there's less air pressing down. It's a beautiful illustration of how interconnected physical laws really are. The bubble itself is also remarkable. It's not a solid thing. It's a thin skin of liquid water surrounding vapor. Imagine a soap bubble but made of water instead of soap. The surface tension holds it together. Molecules on the outside of the bubble are pulled inward by their neighbors, creating a membrane so thin you couldn't see it under a microscope. This membrane is under incredible stress. The vapor inside is pushing outward. The water outside is pushing inward. The bubble exists in that perfect moment of balance. But the moment the bubble reaches the surface, that balance breaks. The membrane ruptures. The vapor escapes. The liquid water collapses back down. The bubble ceases to exist. What's truly remarkable is that boiling water looks the same whether you're in Tokyo or Toronto, whether your pot is ceramic or steel, whether you're using tap water or distilled. The physics doesn't care about those details. The same molecular dance plays out every single time. Invisible, predictable, eternal. This is why understanding the ordinary is so valuable. You've seen boiling water your entire life. But until now, you were watching a silent movie with no subtitles. The bubbles were forming, rising, bursting, all without your knowing why. They were telling a story about pressure, temperature, and molecular freedom. And you were missing it. The next time you boil water, pause, look closely. You're witnessing one of nature's most elegant demonstrations of how matter behaves under stress. Molecules escaping, bubbles rising, pressure pushing back. It's a conversation between forces written in vapor and liquid, and now you know what it's saying. Subscribe to uncover the hidden physics behind the everyday. There's a new discovery waiting in your kitchen.